So guys, today's going to go fast. Today may go a little faster than usual. Today may go a little slower than usual, depending upon how much time we need to spend talking about the thing before the and. After the and, we've got to do, because this is new. Before the and is actually a journey back to September, because we've already done this. You may remember the weeping and gnashing of teeth that happened when the words significant digits crossed my lips. And then you remember the challenge? I challenged you that if you can look me in the eye and tell me that you didn't learn anything as we went over significant digits, because most of you learned it in physics, I would give you a candy bar, and none of you took me up on it. Remember? You don't remember. It was September. You don't remember. But guys, we need to go back over significant digits. Why do we need to go back over significant digits? Because your calculators are in front of you. And if your calculators are in front of you, you understand we're going to be doing math. And if we're going to be doing math, we're going to be wise communicators of accuracy. And so consequently, we need to go over significant digits. When we're done with that, I'm going to teach you to calculate formula masses. This takes about 6 minutes to teach to you, and we're done. So as much time as you need on significant digits, 6 minutes to teach you calculating formula masses, you get your homework done. Shall we? The correct answer is yes, we shall. So guys, there you go. That's up to you. Depending on what your notebook looks like, and if you're one of my children, literally my son and daughter, it means your notebook is worthless as a learning tool because it's so messy that it doesn't even matter that you have a notebook. But guys, if your notebook is anywhere near functional, if you go back to around the 25th, you will find that this is right out of your notes. It's actually a little more spread out than this. Does anyone have a date? It's around the 25th. Is it the 24th? 24th? Okay. So guys, you go back to the 24th. 25th was my B-Day classes. If you go back to the 24th, you will see that you have all of this. It's spread out maybe depending on how you took your notes. And then actually the stuff about multiplication, addition, subtraction, and division is the 2 days later in your notes. But guys, these are the things you need to know about significant digits. There's actually 3 types of significant digits. You're going, wait, then why are there 4 rules? Guys, there's 3 significant digits and yet 4 rules because the last rule says nothing else is significant. You don't need to write it down. So, what 3 types of digits are significant? Those include non-zeros, trap zeros, and final zeros after the decimal place. If it would be helpful for you to have that physical experience of writing this down again, knock yourselves out. If you can look back to August 20, what'd you say, 4th, 5th, whatever it was. It's there, however you choose to do this. But guys, it's important that we remember that significant digits communicate accuracy. How correct are your measurements? And that's why we care about them, because when you're doing math, you've got to identify how accurate is your original measurement so that you can then represent your answers to an appropriate accuracy. Of course, that means we're going to be doing math. So how do we round when we're doing math? Well, the answer is this. When we multiply and divide, we round to the least significant factor. So we count the significant digits and everything in the math, and we round our answer to the fewest. Because remember, addition and subtraction are different. There are no significant digit rules for addition and subtraction. Instead, there are decimal place rules. And so instead, when you're adding and subtracting, when you're doing that, you don't care about significant digits. You care about decimal places. And then you round to the fewest number of decimal places. So guys, I'll give you a second to write down what you need. Again, this is the wild card spot in the morning. The more time you need is fine. But when we're done with this, I want to show you some examples. And then I get 6 more minutes to teach you how to calculate formula masses. And then guys, as you're writing this down, I may as well tell you, for those of you that have taken physics, Remember when we talked about significant digits and you all thought you were justified in groaning because you thought you knew it? Friday is going to be another day like that. Guys, on Friday, we're going to talk about dimensional analysis. So instead of a groan, I get a yay. I like that as well. Same deal, guys. If you walked in here thinking you've got dimensional analysis nailed down tight, I would challenge you on that. If you've never heard of dimensional analysis, that's great. I'll teach it to you well the first time. Guys, if you think you have dimensional analysis nailed down tight, I'll make the same agreement with you on Friday. If at the end of the day you can look me in the eye and tell me you haven't learned anything, I'll give you a candy bar. Again, I've never had anybody take me up on that, but I'd love to. I actually have a candy bar. Have you seen my candy bar? Oh my gosh, but this is not any candy bar. Instead of being, it actually says extra large. They come in sizes. What do they used to call the big ones? King size. Now it's extra large. This could be yours on Friday. Actually, I got it this morning. Yeah. All right, guys, you okay? You're good? Okay, so guys, let's do this. So, it's kind of a weird thought, but follow it. In order to apply, in order to do these things, we've got to do math. And guys, today you're not going to do any math. Well, sort of. We're not going to do a lot of math today. We are on Friday. We're going to add today. You'll be fine. But guys, we're not going to do a lot of math today. We are going to do a lot of math on Friday because we're doing dimensional analysis. So we'll really stress test this on Friday. But we need to make sure we're okay on this starting now. So I would offer you these ideas. Wait a second. Where'd it go? Hold on. I'm missing a slide. It's gone. It's like totally gone. Wait for it. I seriously have no idea. Hold on. Now's the time. He's vulnerable. Get him. Oh. Found it. Doesn't mean I can fix it. It just means I found it. Hold on. Ooh. That doesn't look good. Wow. What do I do? Oh, my life. All right, here we go. Oh, yeah. Yeah, these are your public education dollars hard at work. So guys, I don't know how that slide got deleted out of my presentation, but I just lifted it out of Miss Call's. I'm sorry this is so small. Her board is actually physically smaller than mine, so she scales down her slides. Anyway, so guys, let's do this or not, depending on if you feel you need to. But I think it would be worth at least visiting these to make sure that you're comfortable with this idea of rounding to significant digits. If you want to write them down, knock yourselves out. If you'd rather play along and just watch, but understand the hazard with watching. Guys, if you're watching, there's the chance that you are creating false security, because in watching, all you're doing is demonstrating that you can watch me do right things. So let's play. So guys, for example, and if we only need to do a couple, that's great. But guys, for example, in this number, first question is this: how many significant digits are in that number? All of them, right? None of them are zero, so it's all of them. So then, guys, at that point, we are being asked to round this to 4 significant digits. So remember the drill. You start on the left and you go 1, 2, 3, 4. So those are our 4 significant digits. So now we look at the next digit and we ask ourselves, do we round up or down? The 2 tells us, of course, to round down. So the question then becomes this. If we round down, we understand that we get this. What do we do with the 2 and the 1? Do we replace them with zeros or do we lop them off? Lop them off. And if you're not sure why, do it wrong with me. If you replace them with zeros, now how many significant digits do you have? 6 again, because those are final zeros after the decimal. So the proper thing to do is lop them off. So the principle that we talked about was if you are rounding below the decimal place, remember the word truncate, cut off, truncate the digits you don't need. Is that coming back to you? Okay, so now guys, let's look at maybe another example. And let's go, yeah, let's do that, but I'd also really let's do the first 3 and see where we're at. So guys, looking at this number, how many significant digits are in this number? 4 or 6 or 7? Let's talk. So guys, the gimmies are boom, 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 and boom. They're significant because they are not zeros. So now we got to talk about our zero rules. Final zeros after the decimal count, trap zeros count. Are these final zeros after the decimal? Well, they are after the decimal. They're down this way, but they're not final. Guys, final are the ones that would be out here, the ones at the end of the number, and these are not. So these are not final zeros after the decimal. Are they trapped? No, because there isn't. If there was a 1 there, then they would count because they would be trapped, but they're not trapped and therefore they don't count. You okay with that idea? Okay, so let me clean up this mess and then let's talk. So 4 significant digits. Now we're going to round to 2. So we go 1, we go 2. What does the next 7 tell us to do? Up. So we're going to go 0.0018, and then do we replace with zeros below that? We're all done. Good? Okay. So guys, one more, and then let's move on, unless you would prefer not to. All right. How many significant digits? 3 or 4. Why is that 0 significant? There you go. Do you see it now? Trap zeros. So guys, these all 4 are significant. So now it's telling us to round to 2. So we go 1, we go 2. That 0 is our second significant digit. We look at the 9. It says round up. So we go 8, 1. Now what do we do? What do we do with the 9 and the 2? Do we replace with zeros or truncate? We replace with zeros, right? We've got to put zeros in these places. Now, does that mean this is now 4 significant digits? No, because those aren't final zeros after the decimal. But guys, why is it important to put those zeros? Well, look at what happens if we don't. Yeah, we turned 8,000 into 8 AD. So guys, understand those zeros are important because they change the value of the number. And so we've got to replace them, but they aren't significant digits. Yeah. You guys good? So you tell me, do you want to do a couple more or should we get into the new stuff? New stuff? All right, new stuff. Don't write this down. Guys, this is the new stuff. And we're going to do the new stuff by doing a little review stuff. So here's where we're at. Last time we learned to write chemical formulas for salts and molecules. And you all say, yes, we did. But some of you have got gaps. Again, we're working on how to address that. But, guys, today what you're going to do is you're going to learn how to figure out the masses of these things. All of the chemical formulas that you wrote on the last test, guys, these are all compounds. They exist in bottles. Many of them we have in lab. Soon in lab, you're going to start playing around with them, not in a qualitative way, but a quantitative way. So we've got to be able to figure out how much they weigh. And so this is what is called calculating formula mass. But to do this, you've got to be able to break these compounds down into their elements. And guys, this is what this looks like. Let's do this one together. So guys, write this down with me. Make it big, sort of in the center of your paper. So guys, I think you can think through this. So I'd like to talk with you about it first. And then if you're not sure, I'm going to show you way more than you would ever need to write down just as a way of understanding it. So guys, we've got this compound. Could we be brave enough to name it right off the cuff? Magnesium phosphate doesn't need a Roman numeral. Why not? Magnesium can only be +2. Okay, so guys, this is magnesium phosphate. Doesn't matter, but it is. So, guys, the question is this. How many different elements, hear that again, how many different elements is magnesium phosphate made of? Elements. 3. What are they? Magnesium, phosphorus, and oxygen. Now, guys, here's the problem. Some of you did this on the test. Don't write this down, but some of you did this. Guys, that is not magnesium phosphate. That's magnesium and polonium. Guys, polonium is wildly radioactive, and this would explode and cause like nuclear destruction. Guys, that's not magnesium phosphate. So when we write these chemical formulas, it's important that we do this right, because this is magnesium and phosphorus and oxygen. And guys, that's the skill that you need to have first, is breaking these down into their elements. And it's critical you understand that that O is capitalized, because that tells us phosphorus and oxygen and not polonium. Thank goodness, or we would die. This is not a very good board day for me. Don't laugh. I don't know why it is that my mouse doesn't work, but this does. Okay, so magnesium, phosphorus, and oxygen. You good? How many of each? So guys, go slow. How many magnesiums? 3, right? Because that's what the 3 tells us. Now be careful. How many phosphorus atoms are there? 2, 4, or 8? 2. Guys, the idea is that the polyatomic is PO4, 1P, 4 O's. But there are 2 of them. So the 2, if you will, distributes. So if we've got 1, 2 PO4s, we've got 1 PO4 here, we've got another PO4 there, because there's 2 of them, we've got 2 phosphoruses. Yeah? How many oxygens? 8. Does that make sense? That's the skill you've got to have. So guys, I wrote it like this in my notes. You don't need to write this down if you can do this just visually. But the idea here, 3 magnesiums, 2 phosphorus, 8 oxygens. If that makes sense, you don't need to write this down. You okay? Okay, so try this then. Iron 3 sulfate. And if you don't understand why this is iron 3 sulfate, you probably got a remediation letter. Remember, the 3 doesn't tell you how many, it tells you the charge. Sulfate is -2, times 3 is 6. 6 divided by 2 is 3. This is iron 3 sulfate. My question to you is this. How many of each atom is contained in this formula? Write down your best thoughts, and then we'll talk about it. How many of each atom is represented in this formula? So guys, first of all, what are the 3 elements that make up iron 3 sulfate? Well, obviously one is iron, but what are the other 2? Sulfur and oxygen. Good. It's a polyatomic. It's made of the elements sulfur and oxygen. Now we need to discern how many. So guys, how many irons do we have in this salt? 2. How many sulfurs do we have? 3. Good, because the 3 distributes, if you like thinking of it that way. And then guys, how many oxygens? 12. You good? Okay, so again, I wrote out way more than we need to, but if these thoughts make sense, you're gold. You good? Okay, so guys, this then is what you need to be able to do with that information. You need to be able to figure out formula masses. Write this in your notes. So guys, these are what are called formula masses. Now guys, technically formula mass is a catch-all for two related ideas. If you're figuring out the mass of a salt, we call that a formula mass. If you are figuring out the mass of a molecule, we call that a molecular mass. It probably maybe makes sense to you that you wouldn't say the mass of a salt is a molecular mass because salts aren't molecules. But for all intensive purposes, it's the same thing. You're figuring out how much these things weigh. So guys, in order to do that, what we're doing is we're figuring out the mass of what we call one formula unit of the compound. And a formula unit is just the compound as written. So guys, I'm guessing that for some of you, the wheels are already churning, right? You're going, I'll bet I could figure out how to do this on my own. So guys, if you want to know the mass of a, oh, I love where you're going, Rachel. If you want to know the mass of a compound, what do you need to know? The mass of the elements that make up the compound, just the, thus the things we just did on the board. So guys, if you can look up the masses of the elements, you can then figure out the mass of the compound. For example, if you want to know how much my bike weighs, if you know the weights of all the parts, you add them up and you know how much my bike weighs. But it's not enough to just know that a wheel weighs 800 grams because there's two of them. So you not only need to know the masses, you need to know how many, given what we just did. So guys, what are the units? When we talk about bike parts, we weigh them in grams. When we talk about atoms, do you remember our units from clear back in September? What are the units? Well, first of all, where are the masses? The bitty red numbers, right? But guys, what are the units for those bitty red numbers? Good, they're called atomic mass units. So guys, when we come up with these masses, they will be in the units, atomic mass units. So, let's play. We're going to do two. I would suggest, guys, that you don't write down the first example. I will ask you to write down the second one, but not the first one. So guys, it goes like this. You okay to go? You okay? So guys, it goes like this. Sodium phosphate. First of all, and again, just watch, what is it made of? Sodium, phosphorus, oxygen, yeah? Just like we did before. So, we've got 3 sodiums, we've got 1 phosphorus, we've got 4 oxygens. Is that okay? Okay, so now in order to figure out the mass of a sodium phosphate formula unit, because that's what a formula unit is, what do we need to know? Well, the mass of sodium, phosphorus, and oxygen. So let's go look them up. So you look up the mass of sodium, element number 11, left-hand column, and you see that its mass is written out to multiple decimal places. Guys, here's what we're going to do. We are going to round to 1 decimal place. So we're going to go with 23.0. Again, you don't need to write this down, just trust me. Then, guys, we need the mass of phosphorus. It's right over here. It is a group mate of nitrogen, rounding to 1 decimal place. It is 31. And again, we're just multiplying, right? 3 sodiums, 3 times 23 is 69. 1 times 31 is 31. Now, guys, we need to know the mass of oxygen. Looking on your periodic table, it's 15 and a bunch of change. We're going to round to 1 decimal place, which is 16.0. But guys, what do we do with the 16.0? Multiply by 4, add them up, we're done. And notice, guys, this is a place where our rules about significant digits matter, because what we're doing here is we're maintaining decimal places. So 1 decimal place in each number gives us 1 decimal place in the answer. If you're thinking to yourself, but wait, we multiplied by a 3 and that's only 1 significant digit. We're understanding that those 3s are perfect numbers because you can't have fractions of an atom. Okay? So guys, now let you try one, and then you're going to have about a dozen of these to do, and you won't have homework today. Ready? Goes like this. Chromium 3 sulfate. Oh man, when we went over our test, Knappenberger told us that we were going to have to be able to write chemical formulas, and I guess he wasn't kidding. Yeah, you've got to be able to write chemical formulas, and I wasn't kidding. So, if you had remediation check marks relative to writing chemical formulas, and not just for salts, there are going to be molecules too. Maybe you're in Tyler's boat, and Tyler said, I think I understand my mistakes. That's great. But guys, this is a great litmus test for you. When you get into the homework, if you can't write these chemical formulas, guys, that's the point where you go, man, I need help here. Because you got to be able to do this, and do this right every time. So guys, what I'd like to do is I'd like to get you over the first hump. The point today is not writing chemical formulas, although some of you may still be struggling with it. But I'd like, if you want, to join me at the board to figure out how to write the chemical formula. If you're done with that, keep going. But if you're not there, I want to help you get to the chemical formula now so you can do the new stuff. So guys, this is the way the thinking goes. Feel free to join me if you want. Chromium is +3. How do we know? Because chromium's got more than one number on the periodic table. The Roman numeral tells us to use the 3. Sulfate, off of our ion chart, is SO4 with a -2 charge. So then, where do 3 and 2 meet up? The answer is 6. So then we say, how many 3s does it take to make 6? That's 2. How many 2s does it take to make 6? That's 3. And we put it in parentheses because we need 3 of the entire SO4. So if you were stuck, you now have the chemical formula. Now move forward and figure out the mass, because that's the new thing that you need to be able to do, building on what you were just tested over. So guys, this thing that you're working through right now on the board is your homework. But I'm going to show you a way to do this even easier. Go ahead. That's a great question. So, guys, the question on the table right now is, are the units always atomic mass units? For now and Friday, the answer is yes. On Tuesday, that's going to change. We're going to have a crisis on Tuesday, which is one of my favorite days of teaching in the entire year. It's really fun. But for today and Friday, the answer is yes. Yeah? They are different, and actually it's interesting because the units that are given on the periodic table, they're atomic mass units, right? They're not atomic weight units. So, no, it's not even a typo. It's, again, and I don't know if we talked about this when we initially talked about weight and mass, and it's cool you understand they're different. Weight and mass are different because weight, and I know you know this, but weight is dependent upon gravity and mass is not, right? But because on Earth, gravity is functionally constant, we use them interchangeably. And even at the highest levels of science, including the dudes that put the periodic table together, they give themselves that freedom. You will see other periodic tables where it's listed as atomic mass. They just use them interchangeably. Okay, so guys, watch this. We're going to now do this together, but I'm going to show you a more simple way to do this. This is the way I'm going to do this for the rest of the year. This will quickly be the way you will do this for the rest of the year. And by the way, you're going to be doing this for the rest of the year. This is how chemists do what you just did. Here's the process. So I don't know these masses. Well, I know sulfur and oxygen, but not chromium. So guys, we need the mass of chromium. So we find chromium on the periodic table, and I've got 51.9961, 52 to one decimal place, right? Okay, 52. But guys, how many of them are there? There's 2. So 52 times 2 is 104. Realize I went to public schools. I'm not very good at this. So, guys, you understand? Never mind. 104.0. Like so. So, guys, this is the easier way to do these. Write them down up above. So now sulfur. If memory serves, its mass is 32.1. Is that right? Okay, so guys, 32.1, but how many sulfurs is there? There's 3. So this 3 tells us there's 3 sulfurs. So we've got 32.1 times 3, 96.3. And I'm just going to write it as best as I can right up above that. Now guys, oxygen we've already established at 16, but how many of them are there? 12. So that would be 192.0, and then I've just got to add those up. 192 plus 96.3 plus 104, and if the stars lined up, I get 392.3. And then guys, as Connor pointed out, the units now are atomic mass units, but guys, this is actually the abbreviation for the atomic mass unit. Just the U. So 392.3, is that what you all got? Okay, so here's the thing you're going to see though. Guys, when I did the key to the test, I actually did it like this. Or not the test, the homework, sorry. When you look online, grab your phone if you want, when you check the answers, they look like this. But guys, I would strongly encourage you to not write any of this. Please, it's way too much work. I know you never thought you'd hear me say this, but don't show your work. If you can just do this, that is exactly the way you want to solve these. I gave you the complete explanations in case you're making mistakes. But guys, just the stuff up top. Can we try it that way? Okay. So guys, here's your homework. You have the remainder of the day, which amounts to more than 20 minutes. Any of this that you do not get done will, of course, become homework. We will then meet on Friday, and I would like to have a follow-up conversation with y'all about what we're going to do remediation-wise. Again, I'd love, love, love your feedback, gang. And then dimensional analysis. That's your opportunity to grunt. I just said we're going to do dimensional analysis. There you go. All right. So guys, for those of you that either don't like to or can't look these up on your phones, I will post the answers up on the wall momentarily.